Hi all, welcome to lecture 5 of module 4. In the last lecture, we have seen that a client machine knows only the IP address of this IP address of the neighboring machine, but he doesn't know the MAC address of the neighboring machine. So in order to get the MAC address of the neighboring machine, we have devised a protocol called address resolution protocol. Okay, so in address resolution protocol we have mentioned the MAC address as the physical address and IP address and the logical address of the IP address. Okay, but in this scenario the machine knows its MAC address. Okay? The machine knows its MAC address, but he doesn't know the IP address. Okay, in that case we are using the reverse addressing mapping. Okay, reverse addressing mapping. For implementing reverse addressing mapping, we are going to see three protocols, that is Rarp, reverse addressing resolution protocol, then Bootp protocol, okay, then Dhcp, dynamic host control protocol. Okay, so here today we are going to see these three protocols. Okay, so what are these three protocols? That is the client knows which address, the client knows the IP address, the client knows the MAC address. Okay, he wants to know the what? He wants to know the IP address. Okay, so what? So MAC address is also known as what? It is also known as physical address. MAC address is also known as physical address. Okay, so the client, he knows the physical address and he wants to discover which one. He wants to discover the logical address. Okay, for that we are implementing three different protocols: Rarp, Bootp and Dhcp. First we can see what is this mapping physical to logical address. Okay, this is an introduction part. There are occasions in which a host knows its physical address. Okay, already I have told that the host knows its physical address but need to know the logical address. Okay, so the physical address is called what? Physical address is called the MAC address. So the host or the machine knows the MAC address but does not know the what? The IP address. Okay, so this happens. This IP address is unknown to a machine. This is happening in two cases. First case is that the station can find its physical address by checking its interface, but it does not know the IP address. Okay, the host machine can know its physical address or MAC address by looking at the network interface card. Network interface card is a hardware that is used to connect the networking cable with the computer or the host machine. Okay, so that networking interface card, by looking at the networking or searching at the network interface card, he can find the MAC address. Okay, but he does not know the IP address. Clear? The IP address will not be available in that network interface card. That has to be provided by the server. Clear? That is the first case. The station knows the physical address but does not know the IP address. Next one is, an organization does not have enough IP address to assign to each station. The station can send its physical address and ask for short time lease, which means that an organization requires many IP addresses. It is having many hosts. Okay, so it does not have that much IP address to be assigned for all the hosts. In that case, that organization will request for the IP address. Okay, IP addresses. So how will that stations accept the or take the IP address? They will send its physical address. Okay, they will all the stations will send the MAC address or the physical address, and they will capture the IP address. Okay, and such IP address will be is valid only for a short duration of time. Okay, അത് കുറച്ച് സമയത്തേക്ക് മാത്രം എടുക്കുന്ന IP address ആണ്, short duration of time. Okay, so this is that for these two cases we require the IP addresses. Okay, now we are discussing about the protocols. Okay, that is we are having, again I am repeating, we are having the MAC address in hand. Okay, from MAC address I am going to retrieve the IP address. Okay, for that we are using the protocol reverse address resolution protocol, bootstrap protocol Bootp, then dynamic host configuration protocol. Okay, let us see the reverse addressing protocol, reverse addressing resolution protocol in detail. Okay, so RARP finds the logical address IP address for a machine that knows only the physical address. Okay, അപ്പം MAC address മാത്രം അറിയാവുന്ന മെഷീനാണ്, അതിന് അതിൻ്റെ IP address എടുത്ത് കൊടുക്കും using this RARP protocol. The IP address of the machine is usually read from its configuration file stored on the disk file. So actually this IP address is actually stored in the secondary storage device. So this IP address will not be available in the primary memory or the ROM or the RAM. This IP address is actually configured in a table, that is that table is actually present in the secondary storage device. Okay, so if a system does not have a secondary storage device, then this IP address will be unknown to that system. Clear? So however, a diskless machine, diskless, what do you mean by diskless machine? The machine that does not have a secondary storage device or a hard disk, okay, is usually booted from the ROM. So the device that does not have the hard disk is actually booted from the ROM. Okay, ROM എന്നാണ് അത് ബൂട്ട് ചെയ്തെടുക്കുന്നത്, which has minimum booting information. Okay, the ROM will be having only minimum booting information. This the booting information that contained in the ROM does not have the IP addresses. Okay, it will be having only minimum information required for loading the OS. The ROM is installed by the manufacturer. The ROM is actually installed by whom? It is installed by the manufacturer. It cannot include the IP address because the IP address on the network are assigned by the network administrator. Okay, a system that is manufactured, the system manufactured by a company will not be knowing the IP address. So such IP address will be assigned by whom? That IP address will be assigned by the administrator. Okay, so when we buy a new system, that IP address will not be present in the ROM. It will be later installed in the hard disk by the administrator. Okay, so in that case, if the system does not have a disk or a hard disk, it will be booted from the ROM. Such systems will not be knowing the IP address. Such systems only will be knowing the MAC address. Okay, the machine can get the physical address by reading the NIC, for example. So how the system gets the MAC address? Just by looking at the physical, just by looking at the NIC card. Okay, ആ NIC കാർഡിലുള്ള ഇൻസ്ട്രക്ഷൻസ്, NIC കാർഡിലെ കോൺഫിഗറേഷൻ എടുക്കുമ്പോഴത്തേക്കും he will be getting the MAC address. Okay, by looking at the NIC card he can get the what? MAC address, but he cannot get the physical address, he cannot get the logical address or the IP address from the NIC card. NIC കാർഡിൽ നിന്ന് നമുക്ക് എന്ത് കിട്ടില്ല? IP അഡ്രസ്സ് കിട്ടില്ല. only the MAC address can be retrieved from the NIC card. Okay, but in order to get the IP address, if he knows the MAC address, we use a protocol called RARP. Clear? അതാണ് ഇവിടെ പറയുന്നത്. Can then use the physical address to get the logical address using RARP protocol. Okay, so the station can use the physical address, MAC address വെച്ചിട്ട്, what is physical address? MAC address. Using the MAC address he can get what? The IP address of the machine using the RARP protocol. Okay, so for that they will create a RARP request message. Okay, let us look at the figure. Okay, so this is the host. This host only knows what? This host only knows the MAC address. He knows only the MAC or the physical address. How did he know the MAC address? But just by looking at the network interface card. So by taking this MAC address, he will create a request packet. Okay, and this request packet is broadcast to all the neighbors. Okay, all the systems in that network. Broadcast ആണ്. Okay, unicast അല്ല, what do you mean broadcast? The information will be sent to each and every system that is available in the network. Okay, so So it will be given to this system, this one and also this one. Clear? So this IP address is in the hand of a server called RARP server. Only this RARP server can respond to the message, respond the host with the IP address. അപ്പോൾ RARPയുടെ കയ്യിൽ മാത്രമേ എന്തുണ്ടാവുള്ളൂ, IP അഡ്രസ്സ് ഉണ്ടാവുള്ളൂ. ഓക്കെ, അപ്പോൾ RARP സെർവർ മാത്രമേ ഇതിനുള്ള റെസ്പോൺസ് കൊടുക്കത്തുള്ളൂ. ബാക്കി ആരും ഒന്നും കൊടുക്കത്തില്ല, ബാക്കി എല്ലാവരും ഉണ്ടായിരിക്കും. Okay, so look at this figure. This request is saying what? My physical address is this one. I am looking for my IP address. എൻ്റെ ഫിസിക്കൽ അഡ്രസ്സ് ഞാൻ തന്നിട്ടുണ്ട്, എനിക്ക് എൻ്റെ IP അഡ്രസ്സ് വേണം. Clear? So as soon as this RARP server get the request, he will send a reply packet. Okay, so reply packet will be saying the IP address of this machine. Okay, this is a unicast message. What do you mean by unicast? This means that this message will be sent only to this host. Okay, ഒരാൾക്ക് മാത്രം കൊടുക്കുന്ന മെസ്സേജാണ് unicast. Clear? So by this time, in the reply message, he can get the what? The IP address. Okay, so a request and a reply packet will be created. അതാണ് ഇവിടെ എഴുതിയേക്കുന്നത്. A RARP request is created and broadcast on the local network. Another machine on the local network knows all the IP address will respond with the RARP reply. Okay, IP അറിയാവുന്ന മെഷീനാണ് ഏത്? IP അറിയാവുന്ന മെഷീനാണ് RARP server. They will respond to this request. The requesting machine must be running a RARP client program, and a responding machine will be running a RARP server program. Okay, so the requesting machine will be having what? This RARP client program. Okay, the RARP server will be running the RARP server program. Okay, so this is the working of the RARP. So clear? Next one is Bootstrap protocol, the second protocol. Clear? So this Bootstrap protocol, this is actually a protocol which is actually implemented in the application layer. It's actually implemented in the application layer, and this protocol is installed or implemented in the Bootstrap process. So what do you mean by Bootstrap process? Bootstrap process is a process that will run when a system boots. Okay, system boots up. What do you mean booting? Booting means loading the operating system from the hard disk to the memory. Okay, that is called the booting process. Okay, so this Bootstrap protocol will be running during this booting process. At the booting process itself, they will load the IP address into the system. Okay, so Bootstrap protocol is a client server protocol designed to provide the physical address to logical address mapping. Okay, we are having the physical address, we will take the logical address. Okay, Bootp is an application layer protocol, it runs in the application layer protocol, and it is used during the bootstrap process. Okay, bootstrap process സമയത്താണ് ഇത് യൂസ് ചെയ്യുന്നത് when the computer is initially starting up or booting up. The Bootp message are encapsulated in a UDP packet. Okay, അപ്പോൾ എങ്ങനെയാണ് ഇതിൻ്റെ മെസ്സേജ് പോകുന്നത്? This Bootp protocol is actually integrated or encapsulated or packaged in a UDP packet. Okay, so UDP is actually a transport layer protocol packet that we will be learning in the next video. This will be actually encapsulated or it is packaged in a UDP packet, and this UDP packet is encapsulated in another packet called IP packet. Okay, first this Bootp message is created as a TCP packet. Okay, this TCP packet is again encapsulated into another packet called IP packet, and it is actually sent. Okay, let us explain this Bootp process using a figure. Okay, so this Bootp process actually is actually implemented in two ways. Okay, in two scenarios. The first scenario says that the client and the server is located in the same network. Okay, അതായത് Bootp server, Bootp clientഉം Bootp serverഉം ഒരേ നെറ്റ്വർക്ക് തന്നെയാണെങ്കിൽ എന്താണ് സംഭവിക്കുന്നത്? That is the first case. Okay, second case is the Bootp client is in one network and the Bootp server is in another network. Okay, അപ്പോൾ ഈ രണ്ട് കേസിൽ how they are doing. Okay, that is what we are going to learn. So first one, when the client and server is the same network. Okay, so in this case the Bootp is this client is actually want the IP address, so it is sending the Bootp request, and the Bootp request he does not know the its IP address and also the server IP address. Okay, so instead of filling the field of the source and the destination IP address, the source IP address will be filled as 0 and the destination IP address will be filled as 1. Okay, hope you can see. Okay, source address in 0 item, destination address in 1 ആക്കിയും ഒരു റിക്വസ്റ്റ് പാക്കറ്റ് ക്രിയേറ്റ് ചെയ്യും. Okay, this is actually a UDP packet and this UDP packet is again encapsulated in IP packet. Okay, അപ്പോൾ അങ്ങനെ ഒരു പാക്കറ്റ് containing the source address as 0 and the destination address as 1 is sent to the Bootp server. Okay, so this Bootp server will accept this take this request and reply with the address of the source machine, IP address of the source. ഇവിടെ S എന്ന് എഴുതിക്കുന്നുണ്ടോ? This S means the address of the source machine. Okay, so how they are creating the request? Since this system does not know its IP address, he will create the source IP address as 0 and the destination IP address as 1. Okay, so such request packet is sent to the Bootp server. Okay, so when Bootp server sees this request, he will reply with the source IP address. He will reply with the source IP address, and obviously the Bootp client will get the IP address. Okay, this is the case when the client and server is on the same network. But in another scenario, here the client is in one network, this is one network, and the server or the Bootp server is in another network. Okay, in that case the client will create a broadcast request. Okay, the client has created this request and it is being broadcasted. But here this broadcast request cannot be accepted by the routers that is available in that network. Okay, ഈ ബ്രോഡ്കാസ്റ്റ് റിക്വസ്റ്റിന് ഈ റൗട്ടേഴ്സിന് അക്സെപ്റ്റ് ചെയ്യാൻ പറ്റില്ല. Okay, he cannot accept this broadcast request cannot be accepted by this routers. Okay, for that they are creating, here in this case, for this handling this problem, they are creating an intermediary system. Okay, intermediary system or an intermediary agent. Okay, ഒരു സിസ്റ്റത്തിനെ ക്രിയേറ്റ് ചെയ്യും, ഇൻ്റർമീഡിയറി സിസ്റ്റത്തിനെ ക്രിയേറ്റ് ചെയ്യും. ദാറ്റ് ഇൻ്റർമീഡിയറി സിസ്റ്റം ഈസ് കോൾഡ് റിപ്ലൈ ഏജൻറ്റ്. Okay, so what is the function of this reply agent? This reply agent will accept this broadcast request and they will convert it into a unicast request message. Okay, what do you mean by unicast request message? This reply agent knows the address of this Bootp server. Okay, ഈ reply agentന് ഈ Bootp serverൻ്റെ അഡ്രസ്സ് അറിയാം. Okay, so he will create a unicast request having this unicast request for this broadcast request. ഈ broadcast request into unicast request convert ചെയ്യും. Okay, so why he is converting this into unicast request? Because he knows the address of this Bootp server. Okay, and this unicast address can be accepted by this routers. Okay, and this unicast address will pass this router, pass the internet and get into the another network and reaches the Bootp server. Okay, this is the case. അപ്പോൾ ഇവിടെ നമുക്ക് ഈ ഇതുപോലത്തെ ബ്രോഡ്കാസ്റ്റ് റിക്വസ്റ്റ് നമ്മളിവിടെ സെൻഡ് ചെയ്തത് ഇവിടെ സെൻഡ് ചെയ്യാൻ പറ്റില്ല. ഇറ്റ് ഈസ് നോട്ട് പോസിബിൾ. വൈ? ബിക്കോസ് ദിസ് റൗട്ടേഴ്സ് വിൽ നോട്ട് അക്സെപ്റ്റ് ദിസ്. വി കനോട്ട് അക്സെപ്റ്റ് ദിസ്. Okay, for handling this problem we are creating an intermediary system called a reply agent. This reply agent knows the address of this Bootp server. So what he does, he will take this Bootp broadcast request and convert into a unicast message and send it to the routers. Okay, and it will be reaching the Bootp server and the Bootp server will respond with the IP address of the machine, IP address of this machine. Okay, this is the way. Okay, അതാണ് ഇവിടെ എഴുതിയിരിക്കുന്നത്. The client simply uses all zeros as the source address and all ones as the destination address. Okay, Why? Because he does not know the source address and the destination address. So he will make the source address as 0 and the destination address as 1. Okay. The Bootp request is broadcast because the client does not know the IP address of the server. The broadcast IP datagram cannot pass through any router. Okay. So first he just the Bootp request is broadcast. Bootp it is broadcast, but this broadcast, why it is broadcasting? Because he does not know the source address or the destination address. Okay. So he is broadcasting. This broadcasting message cannot reach the what? The router. Clear? The Bootp request is broadcast because the client does not know the IP address of the server. The broadcast IP datagram cannot pass through any router. Router vadi pass cheyan pattilla. To solve this problem, there is a need for an intermediary system. Okay. One of the hosts can be used as the relay. Okay. അപ്പോൾ ഈ ഇൻ്റർമീഡിയറി സിസ്റ്റം എന്ന് പറയുന്നത് ഒരു സിസ്റ്റം തന്നെയാണ്. ഇറ്റ് ഈസ് എ ഹോസ്റ്റ് സിസ്റ്റം. ദിസ് ഹോസ്റ്റ് സിസ്റ്റം വിൽ ബി ആക്ടിങ് ആസ് ദ ഇൻ്റർമീഡിയറി സിസ്റ്റം ഓർ എ റിലേ. ദി ഹോസ്റ്റ് ഇൻ ദിസ് കേസ് ഈസ് കോൾഡ് റിലേ ഏജൻറ്റ്. ഓക്കെ. അങ്ങനെയുള്ള ഹോസ്റ്റിനെ നമ്മൾ വിളിക്കുന്ന പേരാണ് റിലേ ഏജൻറ്റ്. ക്ലിയർ? ദ റിലേ ഏജൻറ്റ് നോസ് ദ യൂണിക്കാസ്റ്റ് അഡ്രസ് ഓഫ് Bootp server. ഇപ്പോൾ റിലേ ഏജൻറ്റ് എന്തറിയാം? ദ റിലേ ഏജൻറ്റ് നോസ് ദ address of this Bootp server. Okay. The relay agent knows the unicast address of the Bootp server. When it receives the type of packet, the request packet, it encapsulates the message in a unicast datagram and send the request to the Bootp server. Already നമ്മൾ പറഞ്ഞാണ്. അപ്പോൾ ഇങ്ങനെ ഒരു ബ്രോഡ്കാസ്റ്റ് റിക്വസ്റ്റ് കിട്ടുമ്പോഴത്തേക്കും he will create a unicast request and send to the Bootp server. Clear? The packet carrying the unicast destination address is routed by any router and reaches the Bootp server. This packet containing this unicast address can be accepted by any router and it will be routed to the Bootp server. The Bootp server knows the message comes from the relay agent because one of the field in the request message defines the IP address of the relay agent. Okay. അപ്പോൾ ഇത് ഈ റിക്വസ്റ്റ് ആരാണ് കൊടുത്തതെന്നുള്ളത് Bootp server അറിയാൻ പറ്റും. The Bootp server knows that this unicast request is came from which relay agent, because this unicast request also contains the address of the relay agent. Okay, address relay agent അഡ്രസ്സും ഈ യൂണിക്കാസ്റ്റ് റിക്വസ്റ്റിനകത്തുണ്ട്. അപ്പോൾ Bootp സെർവറിന് മനസ്സിലാവും ഇത് ഏത് റിലേ ഏജൻറ്റിൽ നിന്നാണ് വന്നതെന്നുള്ളത്. ഓക്കെ, അതാണ് ഇവിടെ പറയുന്നത്. The relay agent after receiving the reply sends it to the Bootp client. Okay, അപ്പോൾ റിലേ ഏജൻറ്റ് ആഫ്റ്റർ so this Bootp server will be replying with this another unicast message. Okay, so when this unicast message receives this received by the relay agent, it will be transmitted to this Bootp client. എന്താണ് ട്രാൻസ്മിറ്റ് ചെയ്യുന്നത്? The IP address. Okay, that response contains the IP address of the client. Okay, so this is called a Bootp process. Okay, Bootp client and server process. Okay, bootstrap process, bootstrap protocol. Next one is dynamic host configuration protocol. So before going into the details of dynamic host configuration protocol, we need to understand the problem that is being faced in the Bootp protocol. Okay, so the main problem is discussed here. When a client requests its IP address, the Bootp server consults a table that matches the physical address of the client and its IP address. This implies that the binding between the physical address and IP address of the client already exists. Okay, so when the client requests a Bootp server, this Bootp server will be having a table. Okay, so that table contains what? That table contains it contains a table, and this table contains the mapping between the MAC address and the IP address. Okay, അതായത് ഒരു MAC അഡ്രസ്സിൻ്റെ കറസ്പോണ്ടിങ് IP address എന്താണെന്നുള്ളത് is actually mentioned in this table. Okay, so when a request comes from the client, the server will look into this table. Okay, അതായത് ഈ MAC എന്നാണ് വന്നത്, അപ്പോൾ ഈ MACൻ്റെ IP address എന്താണ്? This is the IP address. Then he will respond. Okay, ഇതാണ് Bootpയിൽ ചെയ്തുകൊണ്ടിരിക്കുന്നത്. Okay, this is what done in the Bootp server. Clear? So as soon as a request comes, the Bootp server look into a table The table contains the mapping with the MAC address and the IP address. Okay, that mapping response will be sent by the Bootp server. But what happens when this what happens when this client is moving? The client stationary alla. Since if the client is moving, what is the case? So the such cannot be handled by the Bootp server. Okay, the client move ചെയ്തുകൊണ്ടിരിക്കുകയാണെങ്കിൽ അത് Bootp സെർവറിന് ഹാൻഡിൽ ചെയ്യാൻ പറ്റില്ല. ഓക്കെ, അപ്പോൾ അതാണ് ഇവിടെ പറയുന്നത്. This implies that the binding between the physical address and the IP address client already exists. So the mapping is already exists in that table. Okay, but Bootp server cannot handle the situation when, okay, ഏതൊക്കെ situation handle ചെയ്യാൻ പറ്റില്ല? First one is if a host is moving from one physical network to another. അപ്പോൾ host move ചെയ്തുകൊണ്ടിരിക്കുകയാണെങ്കിൽ it cannot handle this. Bootp cannot handle the IP address because this IP address will be changing every time. So such mapping will not be available in the table. Okay, because that table is actually static table. Okay, now next case, if a host wants temporary IP address, okay, temporary IP address വേണമെന്നുണ്ടെങ്കിൽ that cannot be issued by this Bootp. Okay, so in order to handle both these situations, we will be using the DHCP, dynamic host configuration protocol. Okay, അപ്പോൾ ഇവിടെ ഡൈനാമിക് ആണ് കേട്ടോ. Here it is dynamic, not static. Okay, the static host, a dynamic host cannot handle this Bootp protocol. Okay, if the dynamic hosts are coming into the picture, it can only this DHCP can handle the situation. Okay, so again I am repeating, Bootp is a static configuration protocol. So Bootp is a static configuration protocol. It cannot handle the dynamic protocol. Okay, so let us explain the DHCP in detail. DHCP provides static and dynamic address allocation that can be manual or automatic. Okay, അപ്പോൾ DHCPക്ക് രണ്ടും പറ്റും. ഏതൊക്കെ പറ്റും? സ്റ്റാറ്റിക്കും പറ്റും, ഡൈനാമിക്കും പറ്റും. അതായത് ഈ Bootp പ്രോട്ടോക്കോളായിട്ട് Bootp ആയിട്ടും ആക്ട് ചെയ്യാൻ പറ്റും, DHCP ആയിട്ടും ആക്ട് ചെയ്യാൻ പറ്റും. Okay, so static allocation. So how the static allocation is happening? Already we have discussed. So DHCP acts as a Bootp. Static allocation സമയത്ത് DHCP will be acting as a Bootp. A host running the Bootp client can request the station address from a DHCP server. Okay, അതായത് Bootp റൺ ചെയ്യുന്ന ഒരു ക്ലയൻറ്റിന് it can request the static address from this DHCP server. DHCP സെർവറിന് ആ അഡ്രസ്സ് റിക്വസ്റ്റ് ചെയ്ത് അഡ്രസ്സ് എടുക്കാൻ പറ്റും. Okay, so static allocations, address allocation, DHCP will be acting as the Bootp. Okay, a Bootp client, they can request the DHCP server for the static address and get the IP address. Okay, or the static IP address. A DHCP server has a database that statically binds the physical address to the IP address. Okay, but DHCP server it is also maintaining a table. Okay, it is also maintaining a table, a static table that maps the static MAC address with the IP address. ഓക്കെ, ഇപ്പോൾ DHCP സെർവറിൻ്റെ കയ്യിൽ ഒരു സ്റ്റാറ്റിക് ടേബിൾ ഉണ്ട്. ആ സ്റ്റാറ്റിക് ടേബിൾ വെച്ചിട്ട് കറസ്പോണ്ടിങ് മാക്കിന് എന്താണ് IP അഡ്രസ്സ് എന്നുള്ളത് അത് എടുത്തു കൊടുക്കും. ഓക്കെ, നെക്സ്റ്റ് ഡൈനാമിക് അലോക്കേഷൻ. എങ്ങനെയാണ് ഡൈനാമിക് അഡ്രസ് അലോക്കേഷൻ ചെയ്യുന്നത്? DHCP has a second database. Okay, this is first database. DHCP is having another database. Okay, with a pool of available addresses. അപ്പോൾ ആ ഡാറ്റാബേസിനകത്ത് എന്താ ഉള്ളത്? is having the വേക്കൻറ്റ് IP addresses. അതായത് ഇതുവരെ അസൈൻ ചെയ്യാത്ത IP addresses എല്ലാം വേറൊരു ഡാറ്റാബേസിനകത്ത് സ്റ്റോർ ചെയ്തിട്ടുണ്ട്. Okay, so DHCP has a second database which contains a pool of available IP addresses. Okay, all the unassigned IP addresses are stored in another database. Okay, that is the secondary database. So when a DHCP client requests for a temporary address, the DHCP server goes to the pool of available or unused IP address and assigns the IP address for the negotiable period of time. So when a client or a DHCP client requests for the IP address, he will just assign the available IP address. The DHCP server will assign the available IP address to this client. Okay, but DHCP client ഒരു IP addressന് വേണ്ടി റിക്വസ്റ്റ് ചെയ്യുമ്പോഴത്തേക്കും ഹി വിൽ എന്ത് ചെയ്യുന്നു, അവിടെ അവൈലബിൾ ആയിട്ടുള്ള ഐ പി അഡ്രസ്സ് DHCP സെർവർ എടുത്ത് കൊടുക്കുന്നു. ഓക്കെ, അതും ടെമ്പററി ആണ്. ആ അസൈൻ ചെയ്ത ഐ പി അഡ്രസ്സ് എന്ന് പറയുന്നത് അത് പെർമനൻ്റ് അല്ല, ടെമ്പററി, കുറച്ച് നേരത്തേക്ക് യൂസ് ചെയ്യാൻ കൊടുക്കുന്നതാണ്. വൈ ഇറ്റ് ഈസ് ടെമ്പററി? ബിക്കോസ് ദാറ്റ് ക്ലയൻറ്റ് ഈസ് ആക്ച്വലി മൂവിങ്, ഹി ഈസ് നോട്ട് സ്റ്റേഷനറി, ഹി ഈസ് മൂവിങ് ഹിയർ ആൻഡ് ദെയർ. അപ്പോൾ ആ സമയത്ത് അവിടെ വന്നപ്പോഴത്തേക്കും ഹി വാണ്ട്സ് ദാറ്റ് ഐ പി അഡ്രസ് ടെമ്പററി. ഇപ്പോൾ ടെമ്പററി ഐ പി അഡ്രസ്സ് കൊടുക്കും. ഓക്കെ, ആ ടെമ്പററി ഐ പി അഡ്രസ്സിന് ഒരു ലൈഫ് ടൈം ഉണ്ട്, പീരീഡ് ഓഫ് ടൈം ഉണ്ട്. Okay, after the expiration of that period of time, that IP address cannot be used. ഒരു പർട്ടിക്കുലർ ഡ്യൂറേഷൻ ഓഫ് ടൈമിന് മാത്രമേ ആ ഐ പി അഡ്രസ്സ് യൂസ് ചെയ്യാൻ പറ്റുള്ളൂ. ഓക്കെ, അത് എക്സീഡ് ചെയ്ത് കഴിഞ്ഞാൽ ഹി കനോട്ട് യൂസ് ദാറ്റ് ഐ പി അഡ്രസ്സ്. അതിനെയാണ് ഡൈനാമിക് ഐ പി അഡ്രസ്സ് എന്ന് പറയുന്നത്. ഓക്കെ, so again I am repeating, when a DHCP client requests a temporary IP address, the DHCP server goes to the pool of unused IP address and assign the IP address for the negotiable period of time. Okay, so the IP address assigned is actually for a short period of time, not for a long duration. Such IP address is called a dynamic IP address. Okay, so DHCP can handle this dynamic IP address. Clear? DHCP provides temporary IP address for a limited time. DHCP provides the temporary IP address for a limited time. The address assigned for the pool are temporary address. Okay, അപ്പോൾ ഈ പൂൾ ഓഫ് നമ്മൾ ഈ സെക്കൻഡറി ഡാറ്റാബേസ് ഉണ്ട്. ആ സെക്കൻഡറി ഡാറ്റാബേസിൽ കുറേ പൂൾ ഓഫ് ഐ പി അഡ്രസ്സ് ഉണ്ടെന്ന് പറഞ്ഞു. ഈ പൂൾ ഓഫ് ഐ പി അഡ്രസ്സ് എന്ന് പറയുന്നത് ആക്ച്വലി ടെമ്പററി അഡ്രസ്സാണ്. ഓക്കെ, DHCP സെർവർ ഇഷ്യൂസ് എ ലീസ് ഫോർ എ സ്പെസിഫൈഡ് ടൈം. ഓക്കെ, DHCP സെർവർ ഈ ഐ പി അഡ്രസ്സ് ഒരു ലീസ് എന്നുള്ള രീതിയിലാണ് കൊടുക്കുന്നത്. ഓക്കെ, ഫോർ എ സ്പെസിഫിക് ടൈം. When the lease expires, the client must either stop using the IP address or renew the lease. Clear? അപ്പോൾ ആ എക്സ്പയറി ടൈം കഴിയുമ്പോഴത്തേക്കും, ആ ലീസ് ടൈം കഴിയുമ്പോഴത്തേക്കും, the client has to either stop using this IP address or he has to renew the lease or renew the expiry time. ഓക്കെ, അതാണ് ഇതിൽ ചെയ്യേണ്ടത്. അപ്പോൾ ഇതിൽ DHCPയിൽ കൊടുക്കുന്ന ഐ പി അഡ്രസ്സ് എന്ന് പറയുന്നത് കുറച്ച് നേരത്തേക്ക് കൊടുക്കുന്നതാണ്. അതിൻ്റെ എക്സ്പയറേഷൻ കഴിയുമ്പോഴത്തേക്കും ഒന്നുകിൽ ദേ ഹാവ് ടു റിന്യൂ ദ എക്സ്പയറി അത് റിന്യൂ ദ ലീസ്. ഓക്കെ, ഓർ എയ്തർ ഹാസ് ടു സ്റ്റോപ്പ് യൂസിങ് ദ ഐ പി. ഒന്നുകിൽ അത് സ്റ്റോപ്പ് ചെയ്യുക, യൂസ് ചെയ്യുന്നത് സ്റ്റോപ്പ് ചെയ്യുക, അല്ലെങ്കിൽ അത് ലീസ് ആ എക്സ്പയറി ടൈം റിന്യൂ ചെയ്യുക, അല്ലെങ്കിൽ ലീസ് റിന്യൂ ചെയ്യുക. ക്ലിയർ? ഇതാണ് DHCP പറയുന്നത്. ക്ലിയർ? സോ വി ഹാവ് seen 3 mechanisms for converting a MAC address to IP address or a physical address to logical address. Okay, what are the techniques? Rarp, Bootp and DHCP. Okay, so these 3 protocols are very important protocols. Please go through it. Okay, thank you.